1969 when I was 16. Married Heather in 1976. She's now got that call sign, has had it since 1991. She's also VE7 Delta Radio. I'm a geological engineer. Met Dana at, actually on the air before we went to the University of Toronto at the same time. He graduated before I did though. Moved to Elliott Lake after getting a geological engineering degree and worked in the mining industry. That's Echo Nancy 86, so about mid-northern Ontario, about a 6-hour drive north of Toronto. Got very interested in VHF very early on, actually in 1970, and started working meteor scatter and getting interested in EME as early as about 1972, when I actually ran some 220 ME skids with Louis Anstio, WB6NMT, who was the first 220 moon bouncer. With a lot of help from Fred and Lee Fish, W5FF, K5FF, I managed to get 220 WAS. A lot of others involved in that as well. That's one of the few that have been issued. That was in September '84. Moved back to Southern Ontario in 1987 to FN02, southwest of Toronto. Lived there for 20 years. Still hold the Canadian single up high power record for VHF contests since September 2005. Was president of the Central States VHF Society in 2004. We had VE3WY, formerly VE3BFM, was involved in that, as well as Dana VE3DS. We pulled off a very successful 2004 Central States Convention in Toronto that year, at much prodding from Barry VE4MA, who talked us into doing that. Moved to Grand Forks, BC due to a job change in late 2007, and retired from Rock Wool International. That's not Rockwell, but Rock Wool International, a Danish company, in December 2014. Lots of Drakes, Collins, Helicrafters, Kenwoods, and Yaesu hybrids around here. Primarily been messing with that stuff over VHF. And there's a list of the former call signs. So, okay, we'll move on. Who's this guy? You recognize him, Paul? Hello, Paul.
Nice hair.
Have I lost everybody?
No, he's just got his mic muted. Go, Paul.
Hello, Paul. Anyways, that's Paul with his brand new 1973, I think, Pontiac Le Mans. I was jealous. Had to put that in there. All right. November 1993.
You never showed me that before.
Huh?
You never showed me that picture before.
No, I kept it hidden.
I can't believe it, with the hair.
Yeah, well, mine was looking pretty much the same at that time.
All right.
Okay, November 1993, it's the second weekend of the EME contest. We've had a very successful October weekend ahead of this. The moon is just coming up to 8.5 degrees above the horizon. We're starting to see it in the focal beam of the dish. And Michael Owen.
Crank the audio, Peter.
Oh, Victor Echo 3, Oscar Nancy Tango. It's showtime.
Indeed. Everybody hear that all right?
Try it again.
What?
Louder.
You're kidding.
No, crank it up.
We can't hear you that well.
You're not
It
getting.
was cutting in and out.
Really? Oh, okay. I wonder if this is his mic problem. Let me try it again then.
1296. Nancy Tango. Oscar Nancy Tango. Moon, hello, moon. Hello, moon, hello, moon. Victor Echo 3, Oscar Nancy Tango. Victor Echo 3, Oscar Nancy Tango.
That's better.
Showtime. CQ, CQ, CQ from Victor Echo 3, Oscar Nancy Tango. 3, Oscar Nancy Tango.
Okay, was that better?
Yes.
Yes.
I guess I really need to crank it.
Go crank it.
Okay, so you can tell those echoes are pretty loud. I think they registered something like 10/9 or something like that. It was pretty incredible as the moon came into view of the dish. So Anyways, this all began back in the summertime of 1992 when VE3BBM, Ralph Cameron, got in touch with Dennis Munjam, VE3ASO, and advised them that the management at the Algonquin Radio Observatory had changed hands. It was now run by a couple of people, or several people at York University, who were part of a new government-funded scientific group called ISTS, or Institute for Space and Terrestrial Sciences, one of 7 centers for excellence set up by the Ontario government to promote science and technology education amongst youth. They also were running a space camp, which had seen some success in the previous summer. Dish time cost $1,000 an hour, we were advised, but we approached them with a 40-page engineering proposal that was put together and submitted. We felt that as engineers, most of us were engineers, we could help them with their situation and try and keep them their costs down and help with the education part of it. Dennis, VE3ASO, and myself met with ISTS in middle of September of '92. And shortly after that, we were given the go-ahead. They were actually very curious about how we would pull this off. So we planned a site visit for late September 1992, just to take a look at the site and see what we were dealing with. The purpose we could see on this, and then we had to lay all this out in the proposal, we felt that this was an unprecedented EME opportunity, particularly for moderately equipped stations and stations that had never worked EME before. We were promoting weak signal VHF, UHF activity, particularly EME in Canada. We proposed to develop a long-term relationship with the ISTS people and assist with Space Campus if we could. The other thing we wanted to find out is if we could actually do it, pull it off and be successful. And of course, what VHFer doesn't want to share the dream of getting to operate a dish of this magnitude? So that was, it was something that we dreamed about for a long time at that point. So where is Lake Traverse and the Algonquin Radio Observatory? It's located about 171 miles or 270 kilometers or so, 274 kilometers northwest of the city of Toronto in FN05XW. You'll see some of the surrounding countryside and see what it's like. It's buried deep within Algonquin Provincial Park, it's the largest provincial park, I think, in Ontario for sure, and maybe greater parts of Canada beyond that. To get there, after you leave the paved road, you're driving on 75 kilometers of dirt road, a fairly well graded and fairly wide dirt road, but you do have to keep your watch out for moose and bear and deer and all that kind of stuff. Of course, they're right in the middle of this park. But then you come across the dish, and it sits there and looms large. This we used to call it the catapult. The cherry picker that was parked in front of it was used to get the gear up to the cabin with the help of an overhead winch that you can see hanging off the feed cabin. And that thing was not a fun thing to ride, let's put it that way. We felt it was very unsafe, and we had some interesting moments in that, didn't we, Dr. Owen? Anyways, ARO was established in 1959. And the 46-meter antenna was built in 1966. It was used to make many significant discoveries relating to the formation and destruction of stars or supernovas, astrochemistry, galactic magnetic fields, and was key in the development of very long base interferometry as well. As part of the VLBI network, ARO was still doing crustal plate movement measurements in the 90s and beyond. But this dish had never been used to transmit before, just receive. There's the backside of the dish. You can see the altitude drives and the azimuth drive. Everything above that concrete house there rotates. So, and we'll talk a little bit more about that later on. Dish facts: the dish is just under 46 meters in diameter, 150 feet. The outside 15 feet of perimeter is a galvanized steel mesh. The inner 120 feet is adjustable solid surface, adjustable at each corner of the steel plates. The F/D is 0.4 or 0.5 that's for the entire dish, and 0.4 for the solid surface, or sorry, 0.5 for the solid surface. It has a surface accuracy of plus or minus 1/8 of an inch on the solid surface and plus or minus a ¼ inch on the galvanized steel mesh. It can operate in a 50-mile-an-hour winds. The weight above the azimuth bearing is 960 tons and 720 tons above the altitude bearing. This is the bird bath position, as we called it, with the focal cabin pointed straight and the dish pointed straight up. The building on your right is where we operated from. You'll see some other pictures of that, but this gives you an idea how far we were away from the dish itself and how far it is up to the feed cabin. That top of that feed cabin is pushing 175 to 200 feet above the ground. And there's probably 300 or 400 feet between the bottom of the dish and the control room, all connected with an underground tunnel and many, many, many cables. This is September 1992 when we were doing our initial survey. Dr. Wayne Cannon of ISTS halfway up the feed legs, and a very somewhat scared Dennis, I think, making his first way up the feed legs. At this time, we were not using any kind of safety gear to climb this, but later on, we ended up using safety gear to go up this. That was mandated by the next group that was running the place, the next manager of the place, actually. The next slide is a picture of one of 2 elevation drives. It's a 14.5 horsepower motor driving that gearbox. It's a 40,000 to 1 gear reduction motor to load. And my son, who was 12 years old at the time, looking over and really wishing that he'd brought his skateboard to skate around on the surface of the dish, bird bath position. Some more dish facts. The azimuth drive consisted of 4.45 horsepower, let's call them roller trucks, riding around on a almost 40-foot diameter bearing. It was actually 37.5 feet, with a gear reduction of 30,000 to 1 on the AS drive. The altitude, as I said, was a 40,000 to 1, driven by 2 14.5 horsepower motors. Some numbers there, you can read them about the slewing rate, 0 to 24 degrees in azimuth. And interesting enough, the dish could actually turn plus or minus 215 degrees, centered at 112.5 degrees. I wish some of our contest rotators on our ham antennas would do that. I've got about 15 degrees of overlap, and that's about it. Notice it can only go down to 83 degrees from the zenith. So in actual fact, we really couldn't bring it down below about 8 or slightly on the high side of 8 degrees. So we had to wait for the moon to get to about 8.5 degrees before we would start getting echoes from it. Another picture of the big bull gear on the altitude drive there. Dr. Norbert Bartel in the background looking out over the control room. You can see the control room where the cars are parked down below. And just behind Dr. Bartel is a 350 foot, or down on the ground, of course, is a 300 kilowatt generator, diesel generator, which fortunately came in pretty handy for us, but was a bit of a bane of our existence too, in one way. This is a view from the 60 feet above the surface of the dish, looking down. You can see how small my son looks there. And the next picture, you're actually like somewhere between 175 and 200 feet up in the air here at this point. The feed cabin was 8 feet in diameter and 12 feet long. There's Dennis Munjum, V3ASO, sitting, and Mike Owen with his hands on the railings, looking a little worried sitting up there, but enjoying the view. View over the landscape, you can see hills in the distance, not big ones. There are no big hills in that part of Ontario, but this site was located in a sort of a natural bowl in the earth surface there, further making it less susceptible to man-made noise. Certainly its location, 75 or 80 kilometers from any kind of real civilization, helped a great deal with that as well. It's very scenic, lots of trees, lots of lakes, lots of mosquitoes, moose, bear, black and deer, etc. There's other dishes there. This is an 11-meter dish that was not too far away from the 46-meter antenna, and it was never operational while we were there. There was also, you can't see it in this picture, but just below that, there was a big horn antenna on the ground as well. All of this stuff had been decommissioned at that point. This is called the Master Equatorial Unit. Basically, this is replaced probably now by our shaft encoders. They're very accurate shaft encoders. At the time, they were not available, of course, but most observations are done using equatorial drive through an equatorial drive mode through altazimuth drive mode, although some of the altazimuth drive where you're changing azimuth and elevation instead of trying to simulate an equatorial drive was used for low altitude satellites and stowing the dish. Unfortunately, with a dish this size, you just can't do an equatorial mount. It isn't going to work. So this device actually was a very precise way of converting the Altax coordinates to, or the equatorial coordinates to Altaz coordinates through a very complicated system of precision mirrors and prisms, a polarized light modulator, synchronous motors, and photo multipliers. So kind of old school technology, but a pretty amazing piece of equipment. It's sit right at the where the azimuth axis and the altitude axis intersected on a 5-foot diameter steel pillar, which is encased in 10-feet diameter concrete column. And it's all resting on a completely separate foundation from the dish, which kept it independent of any wind loading or temperature impacts. This is what you can liken to your rotor jumper. Inside the center of the dish, there was this very small room. They called this the twister. And these are just sort of plastic cables that were about 10 feet long, maybe 12 feet long, something like that. And it was through all these that all the cables from the feed cabin and the vertex cabin came down and went to the equipment either down below through several patch panels all the way to the control room. And it was through these that we ran about 4 runs of, well, we didn't run them, they were already pre-run. Finding 4 runs of RG58 that would carry our control signals, IF signals, to the feed cabin was a little bit of a challenge because a lot of the cables have broken over time. But we did manage to find 4 of them that worked for us and worked just fine. This is the Ham M. This is the AS ring, the AS gear. It's 37.5 feet, very highly polished, as you can see. We were actually asked when we first went up there to make sure that anytime we were going to operate the dish, we needed to go up there and check and make sure somebody hadn't left a pop can sitting on it. You just wouldn't want that to happen. I don't have a picture of the actual roller trucks. I'm not sure what happened to that. But this is actually a picture of one of the hydraulic lifts that would lift the whole dish off the Yaz ring in the event of very high winds or if maintenance needed to be done. That's the control room. So this is where we actually operated from. And this is a picture inside the control room. We just operated in front of that rack set on the left-hand side, as you'll see in some later pictures. The big console on the right, just in front of Bob Morton there, is the dish control center. It's not actually the computer that ran the dish at that point, but all the manual controls and the big giant 3-inch Nixie tubes were all lit up and telling us where the dish was pointed. The 32-element interferometer had been decommissioned by the time we were there, but at one time this was used to scan the surface of the sun every day at noon. There was another 1.8 meter dish that was used to scan the 10.7 centimeter solar flux reading every day as well. That has since been moved to the Dominion Radio Observatory in Penticton, about a 2.5-hour drive from where I live here now in southern BC. I should also mention for John WB2BYP that Penticton has 9 Kennedy dishes, 28-foot Kennedys. 7 of them are active and have been for many, many years in a synthesis telescope. So, and then 2 of them are sitting on the ground. I haven't been able to talk them out of that. The staff lodge is where we stayed. The place was overrun by mice, filthy kitchen, quite something when we first got there. In October 1993, when we went back, my wife joined us that first weekend, and she did an awful lot of job of cleaning the place up, cleaning the big refrigerators out, and making it a habitable. It's habitable. It just the bathrooms and everything needed a lot of work. They didn't stay that way, unfortunately. When we went back in '94, things had pretty well regressed by that time. So. November 1992, we planned to operate 432 megs only. It was too late to do October, the first weekend in the EME contest. So we tried for November, got everything ready as best we could. And we decided to use the on-site rack in the feed cabin to mount the 8938 amp that belonged to a VE3CRU. We decided to use circular polarization to try and limit the impact of Faraday. And all the operating was done from the control room. I don't think it was maybe 500 feet away, but certainly approached that. So at 432, the dish has about 43 dBi of gain if you use a 50% efficiency for the parabola. November 92, we stayed over Thursday night in Pembroke, about 80, 90 kilometers away from the dish. There was a huge winter storm overnight with 100-kilometer-an-hour winds. And by the time we got it, we had no commercial power by morning, and certainly there was no power at the radio telescope either. But they had power because of the running the 300 kilowatt generator, kept the lights on and the heat in the buildings. Unfortunately, their policy was that the dish gets stowed when under generator power, and it's not allowed to be moved. The reason we were given for that was the fact that they were worried about the wind moving the dish and generating back EMF that perhaps could damage the generator. We weren't about to argue with them about that. So basically, we couldn't point the dish at the moon, which was pretty disappointing. We decided to go ahead and install the gear and make sure that all went smoothly. So that's what we did, and everything went just fine. We had terrible HF conditions at the time, so we had an awful time trying to get word out to the EME group on 20 meters. That we weren't able to get on the air, that we had everything installed and everything seemed to be working fine, but we couldn't point the dish at the moon. So we waited and waited. Finally, on Sunday morning, we decided it was time to tear everything out and take it away. They did not get power back that night. I don't really know how long it was before they got commercial power back. This is a picture of the 432 rack headed up to the feed cabin via the cable hoist that was on the front of the cabin. A little bit unnerving for those of us who own this equipment, but it actually worked not too badly when the gear motor worked okay, which wasn't always, unfortunately. That's Dennis on the left, Hans, VE3CRU, looking up next to the dish, or to the rack, and Dr. Cannon from ISTS on this side of the rack. So, very disappointing, but we went back much better armed and prepared for another onslaught in 1993. And so with that knowledge, we went back with 3 bands in mind, planning for 432 and 144 over the first 2 passes in October, and 432 and 1296 during the November weekend. Kevin VE3KH fabricated a second gear rack that allowed us a 2-band installation ahead of time so that we could switch from one band to the other very quickly. Bob Morton and Neil V3SST, who is on here today, developed some new quick change feeds for us. We had 3 feeds made. I think they were, well, the 2-meter feed was a 2.5 turn helix. I can't remember how many turns were on the 432 feed. And then I believe it was like a W2 IMU type feed horn for 1296 that was fabricated. And we also made another antenna for 432 with a reverse circular, I guess it was, I don't know, I can't remember which one it was, right hand, left hand, whichever one 1296 doesn't use. We ended up looking for the Mars Polar Observer as a request through Michael Owen from JPL. We didn't find it, unfortunately. This is the 2-meter amp. This is my amp, 8877 amp HV supply in the bottom, which was built initially specifically for this operation over the 1992 and early 1993 time period. You can see connections in the front there in between the HV supply and the amp. 3 connections, TX up, RX down, and a control line. And then there was another line coming off the back from the Bird watt meter pickup from the sensor. And just those 4 lines were all we needed to take everything down to the dish. We had 2 220 volt to run everything up at the feed cabin. Although it wasn't a particularly stiff line, it was enough to make it work. Side view of the rack, you can see the transfer, the SSB electronics transmitter on the back side there, and an intermediate amp above that. And a sequencer in there as well. Readying this is Dennis and Hans and Kevin actually went up early and got everything ready while the weather was lovely. And then the rest of us came up a day or two later in time to operate on the first moon pass. This is the what it looked like with the 432 equipment dangling about 90 feet above the ground. Somewhere I have a picture of my rack cabinet with the dish straight up and my rack cabinet dangling 200 feet in the air. It's a little bit unnerving. There's a picture of the 2 meter feed with its fold out. You can actually see here, if you look, did that work? Okay, there, just in here and on here, this side, there were some detachable or fold out screens so we could expand the rear reflector on this helix that Neil and Bob managed to make for us. So we had trouble getting it out through the door there otherwise, so kind of a neat way of doing it. The 432 helix looked much the same, obviously smaller in diameter. Okay, we're up and running, and we've got moon, and we're making contacts. Kevin, V3KH in the foreground, V3KDH at the time. Kevin was our computer expert. He was very good at getting the computer up and running, not an easy task some of the time, and keeping it running, not always an easy task either. Dennis watching and assisting there as well. In November, Kevin couldn't come back up, so Dennis had to operate the dish, and we managed not too badly at all. Bob Morton in the background with a video camera, Dana behind the lamp, Don Fall in the blue and red jacket to the left of Hans, who's operating probably 432 at that point. Hans was our main 432 operator and equipment supplier. Dr. Owen, believe running 2 meters here, and because that's my IC765 sitting there. To his right, you can see a small computer that Mike brought along, and that's running, you can just sort of see the side of it there. It's actually running his NOVA program, which was kind of a nice backup just to make sure we knew where the moon was supposed to be. And we could check that against the giant Gould computer that ran the dish. To the right of that computer is another receiver that we used to monitor the 10 kilohertz that we had specified we would listen for people between, they think .150 and .160 on each band. And then we would transmit on .150 as I recall. So. Another picture of the group, you can see in the background the Nixie tubes on the big old control console. Don in the red and blue in the front with the headphones on, and Hans on his left. Later on, Bob Morton with the headphones on, Peter, me, that's me on the left. And Bob's son Craig, I'm not sure what he's doing there. He may have a laptop or something he's fooling around with, so. And that's the bunch from 1993, from October 1993. Dennis on the left, Bob Morton, my wife Heather, I'm standing behind her, Kevin in the back, then Don Fall in front, Craig Morton in between, to the left of Dana, and then Hans second from the right, and Mike Owen on the right. That's what it looks like standing in front of the dish. You probably don't notice it, but my wife Heather is standing right there. So I'll give you kind of an idea what it was like to be right underneath that thing. It really was quite something. All lit up. This picture actually made it into the newspapers, which was kind of neat. We had a science reporter from the Ottawa Citizen come up and do an article on us that went, well, kind of viral for newspaper talk, I guess, across the country, and it actually made it to the front page of the front section of the Edmonton newspaper. That was our results for the 1993 contest, AWR EME contest, 235 contacts on 2, 246 on 432. 79 on 1296. 79 contacts in one moon pass on 1296. 235 on 2 meters in one moon pass as well. So worked all continents on 1296. Sadly, we did not work South America on the other bands. And 1296, we worked CX9 BT. I think it was one of his first EME contacts. And so the total came up to just under 6.5 million points. Certainly a score the likes of which the AOR EME contest never seen before. JH1 MOM, one of our happy contacts that we made, an apartment-based EME. So we've got people that complain they don't have enough room, and this is back in the CW days, don't forget. Pretty amazing that he was able to do that and work us with a 4 Yagis on the side of his apartment. Next guy, very happy camper, JK1HIX with a 2-meter dish and only 10 watts on 1296. His first EME contact, and he actually worked us on 2 meters in 1994, the following year as well. KC4YO, travel and trucker, I like to call it. He had a lot of trees around his house, so he had his EME antenna mounted on the back of his truck, and he could pull it out to where they had clearing and he could see the moon okay. So, and we worked in with pretty good signals on 1296 as well. PA0JMV, a 2 Yagi array. This guy had over 500 initials with that 2 Yagi array. I'm going to try playing this, see if you can get this. I'll have to crank it up. Let's see if we can get the audio to work. Okay, getting into that, Paul?
Yeah.
Okay. So that's what that sounded like. The next one, this is PA2GER with a single Yagi, and we'll play this one. Hopefully it'll come through okay. Okay, so I'll give you an idea of that one.
Yeah.
And Tommy, there you go.
The audio is real low. Can you turn it up and try again?
What's that one, Paul?
The audio was really low. Can you turn it up as much as you can and try again? Play it again?
You want to hear that one again? Okay, let's try it again.
Both of them. I couldn't hear the first one either.
We only get a couple of seconds at the beginning and then it goes off.
Yeah, and there's a burst of noise, like maybe something's being overloaded and it shuts down. I'm not sure more audio is correct. It may be less audio to keep it from crashing.
Okay, let me shut that off. I'm gonna go back. Let me try something. I'm gonna put the speaker closer to the microphone, but I'm gonna turn it down. Okay, see if that works any better. This thing does seem to be overloading somehow. So let me try this and see if we get this a little better.
Copy him.
How'd that come through?
Yeah, that came through excellent.
Okay. Okay. Yeah. It's just, I have to play this on the computer speakers, or a nice set of computer speakers, but I think this microphone that I'm using is not great. And like, I think it overloads pretty easily, and that may be part of the problem. So Tommy WAWZG worked us with a single Yagi mounted on his ladder. And I like to say he had a nice brick amp down, right down here, right? Sitting underneath the ladder, keeping it from blowing over. So anyways, Tommy worked this, no problem with that, as I recall. Sadly, I don't have everybody on tape. It was pretty tough to keep fresh cassettes in the tape recorder. Not everybody was really keeping an eye on that. I don't blame them. We had lots to do. And I'll apologize to Lionel right now because you're in the log both in 93 and 94, and yet we missed you both years. So my apologies. I tried hard to look for something, and some of the other VE3s or some of the other VEs also we missed. So not a very good representation for our VE EMEers. So anyways, this is the article that Shelley Page put together for us. Didn't realize it at the time, but she has had quite a life. She was suffering from lupus prior to even going up there, and none of us, I don't think, ever knew that at the time, but I've since discovered that and doing a bit of research. A little bit of the scenery around Algonquin in the fall. Obviously lots of deciduous trees, and the colors are really quite amazing. It's quite picturesque. Heather and Craig spent some time running around on some trails on their mountain bikes. So not that there were any real mountains, but okay, we're going to try some of our high points here from 1993, and I'll do this again. I'll try and get this. I have to pick the thing up to do it, but let's try this out. So some incredibly loud EME echoes. I don't think you have any trouble hearing this one.
Not hearing the echoes.
There we are.
I don't hear anything here.
Oh, it's really low. Probably it's too high again.
Do you have a loose connection on your microphone?
Well, you're hearing me all right, aren't you?
Yeah.
You're hearing me okay?
Yes.
I'm using the same microphone, so. All right, let me try it from back here. I mean, I can't believe this doesn't come through. It's.
Disable agency.
What's that?
Disable the agency.
Yeah, right. Let's try this again.
That's good.
That's
And then
right.
it stops.
Sounds like it's trying to prevent feedback from the computer.
Is that coming through?
Roger?
That's maybe an idea. Try and play it back on it. Maybe not for this time, but maybe play it back on a different computer, not the one you're using for Zoom because of the echo cancellation.
Yeah.
Play it back on it. Well, I should have left the darn thing on a tape is what I should have done. So I'll have to do something different in the future because this obviously is not working. If I ever do this again. Anyways, I apologize for that. I'll just, that was DL8DAT, and he was just like 20 over 9. Big station, big signal. So it's pretty incredible. One of the other things, one of the problems that we had, I'm not even going to try to play this K4YYL on this one. He was a single Yagi, 40 element Yagi on 432, Oscar class station, 100 watts. He spent 8 hours trying to work us, and we made it eventually. And but we had quite a problem with buzzing on 432 on the first weekend in October '93. Hans had used a wall wart to power his receive preamp, his low noise preamp, and it was generating all kinds of crud, and the signals were all buzzy, very hard to listen to, very wearing, let's put it that way. And it turned out, fortunately for the second weekend when we operated 432, we figured out what was causing the problem, and we were able to fix that. But it was pretty trying that first year to put up with that for 12 or 14 hours or whatever it was. And so don't use a wall wart when you have to run your preamps, guys, or anything for that matter if you can help it. So especially these days with digital modes and everything, it's not a good idea. QRM was quite something on 144. Let me try this one, see if I can get something to work here. Is that coming through? I don't know whether you can hear that or not. Were you able to get that, Paul?
Yeah.
Sounds good in Arizona.
Okay, that's good. I'm glad it. You can tell it was pretty busy, and then don't forget that was spread over 10 kilohertz that we were listening to as well. So it was quite something. So, anyways, the other issues, the lower elevation limit, of course, we had to put up with that. That was not a big deal really, but so we missed some moon time at each end. Cherry picker problems. This thing was terrifying, to put it mildly. We had, minimal training. We had a problem with a pinched gas line that had to be fixed at one point. And trying to get it to run in the middle of the winter was, you know, well, not middle of the winter, but even the cold weather we were facing in November was very, very difficult. It just didn't like starting when it was cold. So the second weekend, there were only 4 of us, Dennis, Hans, myself, and Mike Owen. And so with 4 of us operating all weekend, it was pretty tough to stay awake and spend long hours in the chair. There were some issues with the focal cabin, but we were able to survive that one without too much difficulty. So here's some of the stations that we worked, some of the low power guys and small antennas. You can see there's a lot of single Yagis there, both on 2 and 432, and a lot of power levels in the 50 to 100 watt range as well. So tried to pick some of the ones that were all kind of below the 100 watt or at or below the 100 watt level, but it was pretty easy. And don't forget this, I mean, you can do this easily these days with using JT65 modes, I guess, but back then it had to be CW, right? So a little different animal. And 1296, it was at 4 mm, 10 meter dish, so a real nice dish, but 6 watts output. So yeah, some pretty neat stuff there. And JK1HIX kind of topped that list with his 10 watts and his 2 meter dish, I thought. Although the next station with 435 element, presumably loop Yagis, and only 20 watts, and he made the grade too. So some of the wildlife, these guys were running around all over the place, the red foxes. I found out very quickly that they loved jujubes, as do I, or as I did. I don't eat them much now, but back in those days, they were always a treat, and I'd have a bag of them with me, and they would come up to the back of the car when I pulled in the parking lot looking for handouts. So even could feed them at the back door of the staff house. They'd come right up and almost take it out of your hand. Not quite, but they'd get close. So 1994, we were all set to go back for 2 more weekends. We got canceled by ISTS with 1 week to go due to a supernova that they wanted to observe. So that was disappointing, but at least we didn't get up there and then find out we couldn't operate. So we decided to go with 1 band for the entire November weekend, and we just ran 2 meters. We had 299 QSOs and 52 multipliers in that 1 weekend. By comparison, the 2 weekend results for W5UN and K5GW are kind of in the same ballpark. So keep in mind, we had 2 moon passes, they had 4. Admittedly, we were multiple operators. They were probably single, well, I think they were single operators. Their antennas actually had as much gain as the dish at 2 meters, 48 Yagi arrays for both of them, a little different antennas, but both 48 Yagi arrays. We lost 3 dB by going to circular polarization, but I think the fact that we were able to make the 299 QSOs in the 2 moon passes on that first weekend was, or sorry, on the second weekend was probably indicative that the choice to go with circular polarization was a very good one. 10 gigahertz EME. I was not there for this weekend, and there's very little information about this weekend. It was coordinated with the first weekend of the ARRL microwave contest just to try and increase activity. There are many kind of unknown potential issues that with going with a very large dish at 10 gigahertz, which I think a lot more is known about now than it was then. Perhaps anyways, I mean, there'd probably some theories. We did hear some rumblings that it probably wouldn't work for us. There were definite problems. I mean, the worries were Doppler smear, signal noise ratio. You've got a big dish, you're getting a lot of moon noise, and under illumination of the moon. Calculations indicate that you're actually only illuminating about 1% of the surface with this dish. So lots of things to be concerned about. Some calculations had indicated that a 6 to 8 meter dish was probably optimum for 10 gigahertz EME. And I think this is more or less been proven out now. Barry could probably comment on this more than I could. I'm not a 10 gig operator yet, although it's coming. And there's a reference if you want to copy that one down or see this later on Paul's website when he puts it up. That has an interesting article on what happens when you start going above a 6 meter or an 8 meter dish or anything really above 3 or 4 meters. You start to get different things happening. So what happened, we ended up with 0 contacts on the first pass. Second pass, we made 14 contacts, only 10 of which were during the contest. So it was very disappointing. Dish aiming issues, rig problems, and very weak signals, very much weaker than we were anticipating. So it's almost like maybe we had too much of a good thing for 10 gigahertz. 1995, we planned to operate 2 meters on the first pass in October, and planned to try and simultaneously operate 6 meter and 1296 megahertz on the second pass with a 1296, our usual 1296 meg feed surrounded by a 6 meter quad. And then we were going to run 222 megahertz for the last pass, most of which was outside the contest window. Well, the 2 meter part didn't work too badly. Sorry, that's not true. Getting mixed up here. This is getting ready to go up and put the 2 meter gear in the feed cabin in October 1995. That's Larry Kaiser, VE3LK on the left, and myself getting ready to climb the feed legs. Weather was not great. It looks blue sky in the back. It was not. It was raining, a very light rain. We managed to get the gear inside. This is what it looks like. You can see the 2 meter gear mounted on that steel pedestal. It's bolted down, and you can see a rope tied off just for safety, just in case some of the bolts let go. Don't forget this thing's operating on its side when the dish is pointed straight up. Not that it would be for the moon, but it had to be for the installation and the tear out process. We had a steady drizzle from Hurricane Opal for many, many hours prior to this and during as well. This is me, the equipment's in place. This is actually a pretty good picture. It's the best picture I had of the inside of the feed cabin. You can see the equipment sitting here. The 432 rack is just out of the picture below me here. And that's where we would mount it. It wasn't mounted there in this instance. This frame here holds the receiver for I think it was mostly 2.2 gigahertz they were using at that time. The receiver is mounted on this frame here. It's a big tripod, if you will, a big triangle that is on 3 big, what do you call them? Pinion gears? Not pinion gears. What do you call those things? I can't remember. Anyways, they're motor driven shafts, right? Threaded shafts. Jack screw, right. So 3 jack screws and motor driven, that would drive the whole thing in and out so that you could pick up your signal at the true focal point for wherever your receiver was mounted or your antenna was mounted in our case. So our antenna is on the other side of this plate that's mounted out here, and we've got a quick change antenna mount just behind it. This panel up here is one of the many patch panels down through the dish where all the connections were made, and we were able to through trial and error, we're able to find the 4 that we needed. You can see just 4 cables, RG58 cables coming off here for our 2 IF lines and our control line and our bird watt meter output. So we could watch what was happening on the bird down in the shack. And it actually registered almost exactly what we registered right inside the feed cabin as well. So there was no ladder to get out when the dish was pointed straight up like this. I'm ready to crawl out. Larry took my picture as this was happening, and 10 seconds later, we're out on the top. We're just closing the doors, and a bang happens, and everything shut off. And then the power came back on because the diesel generator kicked in. We lost commercial power again. Thank you, Hurricane Opal. This pole, we took a picture of this as we were leaving the site, was about 20 kilometers down the road, and it actually burned right off the top and fell to the ground. There was a part of the cables were right on the ground further up, and so we had the same old problem. The equipment worked FP, but couldn't aim the antenna at the moon. So we eventually had to give up and head for home. This is the path of Hurricane Opal. They actually had 19 inches of rain down here in southern Mississippi, southern Alabama area in one place. And ARO, not right on the track, but we had all this kind of drizzle, not much wind, kind of a warm drizzle for that time of year. And it just never let up. It was actually doing that before I left home on my way up to Algonquin. We had another operator there, pair, SM0DFP, and another fellow, and I can't remember his call sign. He was VE2 was also there. Some of Dennis's friends from up Eastern Ontario area. They were operating the 50/1296 station. It wasn't a good idea to try to operate the two bands at the same time. It really didn't work very well. We had interference between the two stations, so we eventually could only operate one station or the other. So it was a little frustrating, and we weren't doing too well on 1296 that year. I guess I don't have the results here, but we only made 32 contacts on 1296 and only 4 on 6 meters. One of those 4 was W5FF, Fred Fish. You've heard that name before. And we had 6 contacts on 220. Fred was also one of our 220 contacts, and which was kind of nice to operate 220, sort of be in my band. I always wanted to run the big dish on that band as well, but we were a little disappointed that more people hadn't made the effort to get on. So, but hey, that's the way it goes. Dana did an article for the Canadian Amateur. This was done over the February and March issue in 1994, and good picture of the dish on the front cover of the first part of the issue, first part of the story. It was a 2-part article. We had lots of other publications as well. There was an article that I had done that went into the Japanese CQ magazine after it was translated into Japanese. And those guys were just, I got so many wonderful letters from the Japanese about our operation, and I have saved all of those and have them all put away in sort of the scrapbook. We also were 2004, that's 1994, Central States VHF Society. I've got to correct that, sorry about that. And same with Dayton Hamfest. That was also 1994 that we did our presentation there. Mike Owen and I, Dennis, all involved in that. Dennis also presented at the Swedish EME conference. I'm not sure the year though, it might've been 1995. He took that and modded it a bit and did that one. Tommy asked me to come back to the microwave update in Sandusky, Ohio some years later. By that time, my call sign had changed to VE3AX, and so I did it to sort of a recap of things there, and all kinds of radio clubs across the country. Very, very thankful to the Rochester VHF group. After Dennis and I went down there to give a presentation on the event, they gave us a Special Technical Achievement Award, which I still have, and it was awfully nice of those guys to put this together for us. And again, we've got some of the Rochester VHF group on here tonight, and I thank you guys very much. This is Dennis and I accepting that award. So there's kind of the summary. The red ones are the ones where nothing happened, and the other ones are the bands that we operated. So without a doubt, the 1993 ARO EME expedition was certainly a success. I think we can all agree that that's way, but that's true. But where would we stand today if we were to do that same thing again? The EME contest became a 3-weekend contest in 2004, up from 2 weekends back in 1993, 94, 95. Digital modes have certainly dominated the contact scores. There are far more digital mode contacts made now than CW or SSB. But that's made EME accessible to a lot more people, especially those with limited space at their homes. You don't need a giant antenna to be able to work off the moon anymore. In 1993, that 6.496 million points was a record score by far. Not that really winning the contest was our goal, although it was used as a measure of success. And we were placed in a new commercial category. Initially, we were told that we wouldn't get a certificate, but ARRL did issue us a certificate for that operation. In 2010, K1JT and K2UIH combined under the new neighborhood rule, even though they're 6 miles apart. I'm not sure what the limit on that is. I have to read the rules, I guess, but they were 6 miles apart, and they set a new all-time record EME contest score of 6.643200 points in the multi-band multi-op category. They had spent several years improving their score, and it was gradually ramping up prior to this, but by 2010, I guess things fell together for them, and they finally exceeded our score in that 17 years after we set that. And then in 2018, this guy, unbelievable. Like, he's got quite the setup here. Yagi arrays, big dish arrays, UA3 PTW as a single op, which you got to be superhuman to be able to do this. Multi-band entry set a new all-time record with a truly amazing score of 6.752/800. Pretty incredible. To date, those are the only two scores that I could find going through all the EME contest results that have exceeded the 1993 score that we had at VE3ONT. So, hey, not a bad run. Pretty happy with that. And that's pretty much, I guess, all that I had. There's a kind of a summary of everything. 1993 in red being the best year, of course. The other one's somewhat disappointed for parts, but still 299 QSOs, 1994, not bad. 95 was a bit of a learning experience. We did not go back in November of 95, and I have no idea why, and nobody can remember why. So we're still trying to figure that one out. So perhaps we didn't have dish time available to us, but I'm not sure that was the case. May have been fatigue. What does the future hold? Well, the dish is now run by Toth Technologies. You can go to this website or just Google Toth Technologies. It's T-H-O-T-H. And you can take a look. They did have a really good history of the site on there, but it seems to be gone from their website now. At least I couldn't find it the last time I looked. But there was some really good stuff there. Great picture anyways of the dish. I love this one with the Aurora, of course, which is happens pretty often. Sadly, the future doesn't look good for these big dish operations. Things you see how often they're being torn down, and this is one of them. There was another one just recently advertised for sale by the Canadian government. They were looking for tenders to tear down a 60-footer, if I remember correctly, just outside of Ottawa that's been there for years. And so that's another big dish in Canada that's going to meet the same fate as this one. So unfortunate, but that's the way it goes. These things are pretty expensive to maintain. Funding for them is drying up. Other means and cheaper methods of putting large radio telescopes on are being developed. The chime system, well, the chime isn't that. In conjunction with the chime system being done over in Penticton, they are also developing a fiberglass dish that they can put together. I can't remember the price, but it's something like $5,000 or $10,000, and it's about a 10-meter dish, 12-meter dish, something like 12 meters, I think. It's quite something, a 12-meter offset dish. So that's kind of the future, I think. So anyways, in memoriam, Dennis sadly passed away very suddenly. Although we knew he had some heart issues. In March of 1997, he was only 49 years old. So we lost Dennis not that many years after the Algonquin expeditions. Hans passed away, we think, in his early 60s in July of 2000. Some of you may not know that Hans Peters took microwave modules, 2-meter transverters, and made 220 transverters out of them, back starting in the late 70s, and eventually just bought the boxes and the parts from microwave modules and built them up from scratch. So he sold hundreds of them. They're all over the place, and you can probably pick one up cheap these days, although you probably need some oscillator work to put them on GT65 or FT8 or something like that. But don't pass one up if you see one. They run about 10 watts, 10, 12 watts output. And I had one for years, actually. It worked great. Then Larry Kaiser, VE3LK, passed away at 64 years old in October of 2004. Larry famously was on one end of the first transatlantic 136 kilohertz QSO in February of 2001. That story is quite something. You can Google Larry Kaiser VE3LK and find the story on that. It's quite something to see. Finally, if you guys have not seen this movie, you need to. It's become a favorite. It features the Parkes radio antenna, 210 feet in diameter. It is actually the sister dish to the Algonquin dish. Structure is the same. It was designed was designed by the same company that did the one in Algonquin, and it looks the same. It looks very similar. And this movie starts with an interesting scene where the dishmaster, who's Sam Neill there on the right, comes back as an old man and rounds a corner, a bunch of trees, and looks up at the dish. And I know exactly what he felt like when he looked at that thing, because that's how I feel every time I look at pictures of the dish. So, but it's a funny movie. It's based on a semi-true story, if you will, about the getting TV signals to the people on Earth. And if you can find it, grab it and watch it. But you got to watch it about 6 times to get the full extent of the Aussie humor. The UVKs will know exactly what I'm talking about. So, anyways, okay. That's all I got. Let me get out of this, if I can, and come back to the real world. Hey. Okay. How do we do for time, Paul?